0.7 is written, so we will write hour. Okay, like we have hour. 0.75 in minutes. Do you know that we know 25%, 50%, 100%, and we have 75%. So that's same like over here. We have time like 15 minutes, 30 minutes, gap of 15. Okay, so over here same thing we have used. So here 75 hour. Okay, 0.75 hour. If it is 0.7 hour, do you think in hours it will be 45 minutes? I think you didn't understand. I am telling you 1.0 hour. It is proper 1 hour. If it is 0.75 hour, then it is 45 minutes. If it is 0.50, then it is 30 minutes. 0.25, 25 minutes. Okay, 0.00 minutes. You have to understand it like that type. Now 45 minutes is there and 30 minutes in the first journey. Now you have to add them and find the total time journey. So first part says total time journey. Total time journey. So total time journey equals to we can write T1 plus T2 equals to 30 plus 45 equals to 75 minutes. Okay, so in hours it will be, do you know that you must be knowing that 1 hour equals to 60 minutes and we have 75 minutes over here. Then how much in hours it will be? It will be 1 hour and 25 minutes. Yeah, we can write it like this as well. Okay, now second part, average speed of the car. Okay, now average speed of the car. To find the average speed, we use a formula. I'm going to show you formula over here as well. It is distance traveled upon total time taken. We use over here, here distance. I'm going to find out distance. Average speed equals to total distance traveled, total time taken. Okay, I have told you also that this we will use. Average speed we have to find. So what was the formula? That total distance equals to total time taken. Total distance. Okay, upon total time taken. So total distance is 30 kilometers over here, 30 kilometers as well over here. So now the distance is 60 kilometers. Okay, 60 kilometers, but we will find it in meters. So we will do 30 plus 30, 60 and 60,000 upon 60,000 upon 75, 148 equals to 48 kilometer per hour is your answer. Okay. Numerical number 7. It's type of interesting numerical. Over here, a train takes 2 hours to reach station B from station A. Okay, and then 3 hours to return from station B to A. Okay, the distance between the two stations is 200 kilometers. Find average speed, average velocity of the train. Okay, now over here you should be open-minded properly. Like you have to think that from station A to B, the 200 kilometer distance is there. The train is going 2 times. Here you have, I'm going to show you. The train is going 2 times from station B to A and then coming from station A to B. When so 200 kilometer plus 200 kilometer, 400 kilometer is the proper distance of the train to go from 2 stations. Okay. Now first of all we will write given. Okay, given. We will write a train takes 2 hours, time equals to 2 hours. So you can convert it in minutes as well if needed, but I don't think so we will need. Okay, and then 3 hours to return from station B to A. The distance between distance equals to 400 kilometer. We will write. I showed you that why we are writing 400 kilometer, and one more distance time is there, T1 T2, 3 hour, 3 into 60 equals to 180 minutes. Okay, yeah. Over here, find average speed. We have to find average speed. So what was the formula of average speed? Can you tell? Total distance upon total time taken. Yeah. Average equals to total distance. So total distance 400 kilometer. Okay. Upon total time taken. We will do it in hours because we are given the distance in SI unit, not the CGS unit. So that's why we will do it in hours. So 2 plus 3, 5 hours. Okay. 5 1 5 80 equals to 80 kilometer per hour is the average speed of a train. Okay. Now they have second part of the 7th numerical, the average velocity of the train. Now the answer is 0 in the book. Okay. You must be thinking, why is 0? Now I am going to explain to you why average velocity is 0. It is because the train is going from station B to A and coming back station A to B. Now displacement is always 0. I'm going to show you over here. Yeah, displacement is always 0 because like this is the path. Okay, this is the distance. A to B is the distance over here. This is the path, and the distance is the path followed by the body. Okay, distance. Okay, and the this here, the red line is displacement. Displacement is the shortest distance from initial point to the final position. Okay. Now when a body goes and again comes back, the average velocity is always 0 and the velocity is always 0 because it is going and coming back. So always 0. You have to learn it. Now second, average velocity is 0. Average velocity equals to 0. Now you will write the reason by yourself over here. Now let's come to our numerical number 8. Numerical number 8. Okay. A car is moving on a straight path, covers a distance of 1 kilometer due east in 100 seconds. Okay. Find the speed and the velocity of a car. Okay. Given. What is given? Given is distance. Okay. Distance is 1 kilometer. It will be 1000 meters. Okay. Now and our time is 100 seconds. 100 seconds. 1 minute 40 seconds. Okay. 1 minute 40 seconds. Yeah. After this, the speed and the velocity of a car we have to find. First, speed. Now the formula of speed is speed equals to distance upon time. Distance upon time. Distance is 1000 meter. Time is 100 seconds. 0 0 cancel. Okay, 10 seconds. 10 meter per second. This is the speed. Okay, that's why we have used. Now you must be thinking why we are not using 1 kilometer. Why are we using 1000? We are using 1000 because we have to find in CGS, not in SI. Okay. Now coming to the second part, says the velocity. Now velocity will also be same. For velocity you can use displacement upon time. Displacement. One more thing I wanted to tell you, one day we will do it in theory, that distance is always more or equal to displacement, cannot be less than displacement, and displacement can be equal to or less than distance, because displacement is the shortest point from initial to the final point of the body. Okay, so now displacement is as well as 1000. Displacement, if displacement was given in the numerical 2000, you just have to write it cannot happen, displacement cannot be more than the distance. Okay, now over here time equals to 10 seconds, same thing use. Okay, 100 0 0 cancel. 10 meter per second. In question we are given that due east. Okay, due east, the direction is given. Now there are scalar quantities and vector quantities. In scalar quantities we just know the magnitude and the numerical value. Okay, numerical unit as well. But in vectors the velocity comes, and in scalars the speed comes. In vectors you just need to, if you want to express a vector quantity, you have to express it in you have to express direction, magnitude as well as the numerical value. So over here we will write due east. Okay, this is the direction. Okay, and this is the numerical value, this is the constant value. Okay, this is the magnitude, this is the numerical value, this is the direction. Now you can easily you have easily expressed the vector quantity, which is velocity. Now question number 9. Question number 9. A body starts from rest and acquires a velocity of 10 meter per second in 2 seconds. Find the acceleration. Very easy question. What you have to do is write given. After writing given, you have to write velocity. Velocity, we will write final velocity. So we will write this. You have you just have noticed that why are we writing, like over here I as well as write direction, here you can say direction over here, as well as I'm writing direction. I told you in this numerical that we need direction to express, so that's why we will use this symbol in front of the v. Okay, then velocity equals to, this is the final velocity. In initial velocity we write u, and final velocity we write v. So v 10 meter per second. Yeah, time 2 seconds. Now acceleration, it's new to us. Acceleration is the rate of change of distance with time. Okay, speed with time. Acceleration formula is v minus u upon t. Okay, so over here v is 10, u is 0. Okay, u is the initial velocity. Suppose we have a car. Okay, we started the car from how much speed? We started at 0. Most likely we said 0 and ended with like this value we know, 10 meter per second. So it is 0 over here because we are not given the initial velocity over here. If we were given the initial velocity, we would have written over here and did the subtraction over here with the final velocity. So we will write 10 minus 0 upon 2. 0 equals to 10 upon 2. Acceleration is 5 meter per second. Okay, now the 10th numerical is same. You will do it yourself, and we will do another numericals in the next video. Thank you for watching.